We meet again.
Hey, man. Brought your shirt from CES. It's got a race car on the back.
Somebody switched teams. For those of you in the know, this is Allyn, and he is really good at storage. And you're now with Phison?
Yeah.
And there's a lot we got to talk about with storage. Mm-hmm. Let's dive in. A lot's happening in storage. And I'm actually really excited about this because 2024 is going into an era where PCIe Gen 5 redrivers are generally available. Phison's got their new high-end controllers. There's not just one high-end controller. There's actually several.
Redrivers and retimers?
Oh, yes. Would you look at that? We've got quite a few of those. Because you have to have those for PCIe Gen 5.
Phison makes those.
How else are we going to do 16 gigabytes per second on just 4 PCI Express lanes?
Well, yeah. So we got 2, 4, 8, and 16 lanes.
I need all the
redrivers
lanes.
and retimers. Yeah. Those are the things you'll usually see. Usually see the smaller ones peppered on some consumer motherboards just to help get the bus further.
They only do it 4 at a time.
Typically, yeah. They could use the bigger one, but the pricing scale is a little, steep.
You see servers using the higher density ones because they don't have the board real estate. Whereas your consumer motherboard, it definitely does have the board real estate.
Right, and also sometimes it's easier for a small motherboard to just have the 2 or they'll usually use multiples of the 4, but trying to do routing for that many pins for the 16, it's more difficult than just having a couple or 4 4s in a row.
Well, you've got all the lanes, which are pairs.
Yeah.
And then you've got all the sideband channels, also pairs.
Yeah.
And then you got all the grounds to guard for the signal bleeding over. And then everything is really close together. And everything can't wait to tunnel into everything else.
Yeah. Basically.
Fun times. The other thing that's driving all of this is changes and upheaval in flash media. Density, of course, but also speed. We got to overclock the NAND. Kind of.
You need the whole SSD to go faster, so you got to push the NAND harder. I mean, they do NAND binning with respect to what the bus speeds that they can transfer at. But yes, we're pushing they're pushing the bleeding edge on this. It's to the point where you have to be really careful on placement on we have a prop.
Yes, so this is the E26. Okay, so this is the one that I've taken a look at, and it is pretty legit. It is surprising how fast it is. But also, the overkill heatsink, really?
You don't necessarily need this if you have a reasonable amount of airflow and a heat spreader. You need at least the heat spreader. You can't run these drives bare.
So on the Asus W790 Ace, I've already tested this.
Yeah.
The M.2 heatsink is just a flat piece of metal. And it is just barely good enough under the torture test worst case scenario.
Yeah.
But it is just barely good enough in a regular ATX layout. So you wouldn't need this, and that's sort of the worst case scenario. If you're not riding Baldur's Gate to the game 10 times in a row, or to the game to the drive 10 times in a row, it's fine.
Yeah. The key is in the controller, like this controller chip, the actual controller die is an even smaller square in the middle of that square, and without something on top of it, it's just too much wattage coming out of too small of an area.
And you got to have a little bit of airflow in that area. Otherwise, the air is not going to carry the heat away, and you're going to have a problem.
Right. Our CES demo, actually, for this, which I'll send you some pictures you can use for B-roll, but we had Chris Ramsayer is a fan of very large cases, actually, just like yourself.
Big case fetish.
Yeah. But he had really big case. He had E26 underneath the stock heat spreader from the board. It was a system that was using the iGPU because we were just trying to show off storage. We didn't have a discrete graphics in there. But it was a case that you only had the front fans and the top fans, and it was just in one, out the top, your standard sort of configuration. And that was plenty. And I had that drive doing a continuous workload in iometer for hours at a time, and it was pegging it the whole time. And I think it was stable at 69C.
Yeah.
And that was adequate, right? So depending on your use case and your airflow, if you have an AIO on the motherboard and you have a configuration that has a lot of stale air around the motherboard, then yes, you would leave that on there, or you would have something with some sort of active cooling, but only as necessary.
The only other artificial situation that I've encountered for our testing was we were using a 4080 that exhausts its hot air directly onto the motherboard, which is not a great design. And it's just that one 4080. The reference 4090 was fine.
Yeah.
And the M.2 being directly under the GPU, that also was not a great situation thermally for this. This thing is I don't want to think about it. You just throw it in there.
Yeah.
And so for those of you in the audience that would buy this, it is... You just use this, and but there's another section of you that I will never buy anything with a fan smaller than 120 millimeters. And for you, also fine. Just make sure that you put it in a slot on your motherboard that has a little bit of airflow, just a little bit. Doesn't need a lot.
Well, and the first generation of these, there was no way to get these that didn't go 20,000 RPM. So, yes, totally understand from the 1U server world also that the high RPM fans can be quite annoying. Just because this one is small here on this heatsink does not mean it's crazy high RPM. Like, it's actually barely audible for this particular configuration now. So the small fan tech is maturing.
I could hear it with the side off, but I don't know if I would hear it if it was buried in a system under my desk. Maybe.
Yeah, it really isn't that bad. Nowhere near as bad as it used to be.
Yeah, I was actually delighted that it worked with the non-heatsink on that motherboard. So, but that's the E26. Now you guys actually go all the way up to the E31, and bigger is better, right? Higher, more number is better.
Kind of. So there's an E27.
Look at that.
E27T.
So these are more low power. Something we ran into on the Steam Deck is that, you could cram a 2230 in there, but it's going to overwhelm the power delivery capabilities in at least the first gen Steam Decks.
Yep. So this is slightly lower power, more about tuning to get better performance.
Performance per watt?
Performance per watt versus the E21T. The performance is actually pretty significant. There's some slides I can send you. You can, show up as B-roll. The PC Mark 10 storage tests, these guys are upwards of double the score over the E21Ts or the E21s. So
so what you're saying is I may have an upgrade for my GPD win, which takes a 2230
or your Steam Deck that you got hiding over there. Yeah,
I can go to 2 terabytes finally.
Yeah, so the Steam Decks went from, I want to say it was E13 to E19, and then right now you can purchase, in the 2230s, we're selling E21s, and this is the next guy. It's not out yet, but it's coming.
I'll be able to pack in 6 terabytes in here with the 2230 plus the 2280, but also without it being insanely high power draw. You see, that's the thing. I don't want to hurt my 8 to 11 hour battery.
Yep. We do a 2280, but we don't, we're only doing 2 packages on it, which means that the max you're going to hit right now is 4 terabyte given current media as well. So don't let the 8 terabytes entice you too much. It's just we can get there, just not
that's why I said 6 terabytes, because I got the 2280 plus the 2230.
Yes.
So 2 plus 4.
That's true. Yeah, you can get there. So now we can get even more power efficient. However,
this is transfer per watt. It still takes a lot of power.
This is not. No, we're talking half the controller power.
Oh, really? Wow.
Yes.
That's shocking.
Well, it's because we're dropping to 7 nanometer.
Oh.
Okay. And
so this is a 7 nanometer process.
And it's obviously not fully baked by the fact that I'm showing you. This does not. Hold on. Need the appropriate prop. This thing eventually turns into something like that.
Now, this is really fascinating because this is your giant heatsink, but also this is a socket, so you can swap in different revisions of the controller. As you do different silicon spins, you just pop it out and pop it in.
Yes.
And also with your media.
This is the flash.
That makes bending media easy when it's in a socket.
Yep. And, we're showing this thing off so we can get even fancier. So there's the die, and this is a BGA socket, which means that I can actually...
Boop. Boop.
There's a controller. In case you want to know what an SSD controller looks like out of a board.
The highest end Gen 5 SSD. Some assembly required.
Exactly.
And this is just your good old motherboard interface. This would plug into your motherboard. And all of the rest of this provides lots of insight and diagnostics and control for somebody that might be working on this.
Right. Yeah. So this is not going to be the highest performer, obviously, but the power consumption and the performance per watt is certainly going to be significantly better.
So this would be appropriate for like a laptop or something like that, because you got some really impressive IOPS numbers here. 1.5 million looks like.
Yeah, we can still hit good numbers, but the sequentials are going to be just under 11. They're not going to be 14 like the maximum. But still, for most people, and especially if you can do that in a significantly tighter power budget, it's more than enough, right?
I like behind the scenes for how the sausage is made, and this is definitely a big part of how the sausage is made.
This is totally how the sausage is made.
This is the human part. The human part has to figure out the characteristics of the silicon and the characteristics of the silicon at scale. Because, like I say, we really are. You're bending NAND, but also how do you even fine grain? How do you come up with the parameters to bend? How do you fine grain the bend? And it's somebody working at a test platform like this to say, okay, well, if we do this, or if we add this extra weight state, or we do this for this electronic design, and we get to this other spot, and then we're good to go.
Yep. And then we have extra ports on these dev boards just for we can flash the controllers on the fly. Makes it much easier.
It's a computer within a computer.
Now we get into stuff Wendell likes even more.
Yeah. So this is new form factor stuff, and before we even talk about the new form factor stuff, so like this is something really awesome. The E1.S 4 terabyte. Okay, so why is this important for the enterprise? The most succinct answer that I can give you is, given the same power and performance envelope, this will outperform its M.2 counterpart by 20 to 40% just because it's physically bigger and physically has better room for heat dissipation and better room to optimize the PCB design.
Yep. And this is going to be in a server that's going to have minimum linear feet per minute airflow requirements, right? So there's some other assumptions on how you would install it. You're not worried about having to put little M.2 fans on this guy just by the nature of how the server would be configured.
Yeah, fundamentally, it changes the equation when it doesn't have to be on a card so small.
And this is the guy where you'd want to have a little bit more capacity than you can fit, basically more PCB space.
E3.S.
E3.S, yep.
Now, you could totally put 30 gigabytes on this form factor, but it's going to be wildly 30 terabytes.
Yep.
30 gigabytes would be pretty easy. 30 terabytes is doable, but you're using the highest density chips and binning, and it's non-linearly expensive.
Yep.
Whereas with this, well, heck, you can, even before you go to more than one PCB, you've got a lot more real estate here to just pack the chips on both sides.
Yeah.
And that's going to be a way less cost effective, or way less cost overall, way more cost effective.
Yep. And notice they are making them thinner than the, 13.5?
Yeah, 7 millimeters.
Yeah, 7 millimeter. So you can have a bay in a server. It has to be obviously 2U for this sort of guy to stack them vertically like that across. But, higher power or higher storage density there. And then if you really want to go crazy, this is the guy that'll go up to 128 terabytes.
The other thing that I really like about E1 and E3 is that it's the same connector electrically, just different physically. And so, like, if you needed to have a physical adapter for that, that is no problem as long as it's also got room vertically.
Yeah, and that is effectively a more dense version of what's on the U.2.
Yeah. U.2, this connector is designed to be nothing bad happens if you shove it into a SAS connector, serial attached SCSI, which is what this inherits from. And so this itself was a connector designed with backward compatibility in mind, whereas this was designed from the get-go for PCI Express. And so this has a lot of advantage. Well, one of the problems with this is that it's really hard to get Gen 5 signaling through that connector. This is a lot easier.
Right. Yeah, it's at Gen 5 speeds, literally the thickness of the traces of the contact pads is an issue. Right, you're having to change the voltage present on a wider area of copper. Oh, that's actually gonna impact and cause you to have standing waves and other weird things going on when you're transferring at those speeds. So the smaller you can make the pins, the better. And even the signaling leading up to the pins, right? There's some compromise you have to make even getting the traces out to these pins on a U.2 versus where these connectors were designed more with that in mind. So the pairs are pairs right up to the pins more frequent, more often than the other connector.
Well, and this connector is also literally part of the printed circuit board manufacturing process.
Yeah.
There is no connector. It is the PCB. Whereas this is a whole let's solder a thing to a PCB.
Yeah. This is about as far as you can get to convert a U.2 to a PCI. That's about as far as your traces.
Without having a redriver.
Right.
Yeah.
Yeah. It's extremely intolerant
not a lot.
of length and going through multiple connectors.
And I guarantee you the bottom slot on an Asus WRX80 motherboard, is not going to work.
Yeah,
it's only going to work in
Gen
the
5.
upper slots.
Right, yeah.
Well, a Gen 4.
Yeah, even Gen 4, I've had Gen 4 drives regress to Gen 3, having to negotiate a Gen 3 in the bottom slot.
We have a lot of experience with that at the Level 1 forums. I'm so sorry. A lot of suffering. A lot of suffering. This so far, so like using the Gen 5 connectors, I've got some M.2 to EDSFF, which is this is not what this is, but it was a version of this where they were going to adapt it to the PCB. It's like just a PCB style connector is what I'm trying to say.
Yeah.
And that with the redrivers has worked exceptionally well. And the E1.S adapters with the M.2 redrivers have also worked exceptionally well in terms of like I can buy the cables off AliExpress and have a reasonable experience getting that to work. And that's also been really good. Some of the TRX50 motherboards have the MCIO connectors, which is again that same style of built-in PCB connector.
Yeah.
And that has been so good compared to the experiences up till now.
So in the vein of your spiffy little favorite laptop lately, we have something coming that might help you with that, and that's
USB 4 SoC.
I didn't want to bring that demo also because that dev board is basically the same as the other dev board I already showed. I didn't want to do two dev boards in my luggage.
USB 4. The reason it's exciting is because USB 4 and Thunderbolt 4 have actually forked a little bit. Mm-hmm. Thunderbolt 4 actually has a limitation when it comes to using it in the context of block device transfer.
Yep.
So I mean, you want to fill us in on it's like why isn't it fast?
Well, I'll just put it this way: it's easier for us to make a native Gen 4 native USB 4
PCIe tunneling.
Right, PCI tunneling chip. Right, have a controller where you're not having to make. This would be really handy for external. I'm talking small portable externals.
Like a USB stick, but you plug it in and it's 2 terabytes and fast.
Right, like think essentially this sort of form factor, because this controller is about that size. It's a little bit longer, right? Maybe a few millimeters longer, but you could potentially have a device in this form factor that could link at USB 4 and give you upwards of with our chip we were demoing 3.9 gig per second.
Yes,
at CES.
And 3.9 gigabytes per second on a Thunderbolt 4 interface is difficult to impossible to do,
right?
Because of the DMA architecture and some decisions that were made in Thunderbolt 4. Yeah, Thunderbolt 4 is much longer in the tooth than many people realize.
Yep.
And so this is one of the first meaningful divergences with USB 4 where you can actually get a chip on the market that is using native PCIe signaling and encapsulation so you don't lose the overhead. You can truly transfer at 3.9 gigabytes per second, as was in your CES demo, which is one of the more interesting things going on, in my opinion.
Yeah, and that was with a laptop that wasn't particularly, it was good enough to have USB 4 on board, but it wasn't like a fire-breathing gaming laptop. It was just a regular old.
Well, for my use case, I could run a GPU off of the Oculink connection on my GPD Win,
right,
and then a game drive off of Thunderbolt and have the best of both worlds.
Yeah.
Well, USB 4. Run a game drive off of the USB 4 connection because AMD.
We have a thing coming. I can show you the case.
Okay.
We can't open the case. This is like Pulp Fiction.
Don't open the case.
We're doing some AI stuff.
So we're just going to assume that there's something amazing.
There's cool stuff in there. May or may not involve us taking our SSDs, and since we could just run them in SLC mode, that's sort of trivial. This is essentially a solution that lets you do machine learning workloads with limited GPU resources by swapping in and out of the SLC. Right, that's the gist.
So you'll be able to expose the memory space of the GPU directly over PCIe by using storage as the backing store.
Yeah. So what you can end up doing is more with less, right? You don't have to buy 16 6,000 ADAs to do a particular thing. You might be able to get away with 4. It's going to take longer, but you can do it, right? You don't have to get the crazy wide.
The magic of PCIe to PCIe memory storage devices.
Right. So coming to a relatively medium to large system builder pre-configured system near you at some point.
So in a nutshell, Phison has a bunch of controllers across a bunch of different verticals and use cases. I'm taking a look at the 2 terabyte E31 maximum, max 14. It is a lot of fun loading games on it, and it is really fast. It's probably the fastest M.2 you can get right now. Truly Gen 5. That's probably going to be better in an AMD platform because your Gen 5 lanes on Intel come from the GPU and the motherboards that exist out there. They'll eat into your GPU connection if you use it.
You know that I go where the fast storage is, which is why I went to the Phison.
Well, I mean, they really do make like an insane number of devices and controllers. This is so funny. It's like I was using Phison controllers in 2007. That's what's inside this USB.
That's what's inside he's using it as a back card for the retimers, but it's actually an SSD.
That's something that I worked on commercially from the dawn of time. And yeah, it was a programmable Phison micro in there, and you could run your own stuff on it, and it doesn't have to be a storage device. That's a USB storage device, but it could have been anything. It doesn't matter because and at that time Phison was tiny. Like it was SanDisk and Phison, and SanDisk was like, where's SanDisk? And now Phison is like, I'm the juggernaut.
I looked at Phison, I was like, I wonder if I could use my particular set of skills to do some damage over there, right? So,
exciting time.
We'll see what happens. Maybe I can ramp it up even crazier.
Yeah. Well, so be sure to check out our full benchmarks on the maximum, and stay tuned if I end up upgrading my GPD laptop. We'll see. It's the thing with the GPD is I don't want the fastest thing in it. I want the thing that's not going to murder the battery. That's the thing. But also fast is nice as long as it doesn't murder the battery.
Hey, still close to 11 gig a second.
And that's kind of the story with the Steam Deck too. It's like it's got to be fast, but also the Steam Deck is already a little bit on the struggle bus with the battery life because I'd really like to have like 5 or 6 hours playing a game, and it's more like 2.5.
We were demoing. We had one of the newer OLED limited Steam Decks at CES, and we had the E27T in there already, and it was like even flipping around in the UI was noticeably faster. For anything that it had to fetch as you were inputting, it was a noticeable difference.
Interesting.
Yeah.
I'll have to give that a try. Fun times. Well, thanks for coming over.
Yeah, brought the CES to the window.